Alright, good morning, guys. This is Mr. Ellenbecker here. I apologize I'm not in class today, but I'm at an appointment I need to be at. So we'll still do one section just because on EL day I don't want to get way behind. And I'm going to go through proofs, which can be kind of a challenge. So we'll go through these together. You'll have plenty of time to work on things in class. And I can answer any questions we have tomorrow when I'm back. If at any time I go too fast and we need to pause or just give people a chance to catch up, whoever is my sub or Miss Walker, if you guys could just hit pause to let people stay up to date with it, because I'm making this recording in front of nobody, so I don't know how long it may take to write. If I run fast, just pause it. Alright, so on to section 2.6. It is on proving statements about angles and segments. Our essential question is, how do you write a proof we will talk about what is a proof. Because none of you have probably done these before. So we're going to kind of just intro this, and it's going to take a little while to understand what we're really doing here. So if you struggle at first, just keep with it. You will get better as we go forward. So how do you write a proof, and what is a proof? And we're going to focus on proofs about segments and angles. Some definitions. A proof is a logical argument that shows a statement is true. Okay, we're not going to say it's true just because. We're going to give a reason why it is true. A two-column proof is numbered statements, and there's corresponding reasons that show an argument in logical order. And then a theorem is a statement that can be proven. So our first example is a four-step proof. We have a picture over in the right corner, and it asks us to use the diagram to prove that the measure of angle 1 is equal to the measure of angle 4. Okay, so in the picture, if you look, you can see that two of those angles are congruent. Angle 2 and angle 3 are equal to each other. So that is given to us. They tell us the measure of angle 2 is equal to the measure of angle 3. They also tell us the measure of angle AXD is equal to the measure of angle AXC. So in every proof, you always start with the given statement. So no proof should ever be blank, because everybody can write down the given statement. In this case, it's measure of angle 2 equal to measure of angle 3. And they also tell us the measure of angle AXD is equal to the measure of angle AXC. And these are the given statements. It's what we know based on our picture or based on what they told us. So there'll always be this part. Okay, and then we're given that AXD is equal to the measure of angle AXC. Whenever they give you an angle like that, you should always see if you can say something about that angle. So in step 2, we're going to try to write something about angle AXD. Okay, because they told us something about AXD, it's equal to AXC. We're going to figure out what can we conclude or what can we say about this. So if you look at AXD, there are two parts to it. There's two smaller angles in there. the two smaller angles are angle 1 and angle 2. So what we're going to say is the measure of angle AXD is equal to the measure of angle 1 plus the measure of angle 2. Okay, and we're not trying to like get right down to the end, angle 1 equals angle 4. We're just trying to say anything we can about AXD. In this same step, we can also say something about AXC. If you look at AXC, from A to X to C, there are also two angles, angle 3 and angle 4. So we know that AXC is equal to the measure of angle 3 plus the measure of angle 4. Okay, so again, they gave us AXD and AXC. We concluded that AXD is equal to angle 1 plus angle 2, and AXC is equal to angle 3 plus angle 4. And the reason we can say that is we've talked about earlier this year, we took two smaller angles and added them up to get a bigger angle. So our reason is angle addition postulate. So step 2 was angle addition postulate. If you add up two angles, it equals a bigger angle. Now down at step 3, we know that AXD equals AXC. What we are going to do is replace AXD with measure angle 1 plus measure angle 2. So instead of saying AXD equals AXC, we can say the measure of angle 1 plus the measure of angle 2 is equal to, we're going to replace AXC with this part, the measure of angle 3 plus the measure of angle 4. So take a second and write that down. So down in step 3, we took what we were given in step 1, AXD is equal to AXC. In step 2, we talked about how AXD equals angle 1 plus angle 2, so we replaced that with AXD. And like we talked about on Tuesday, like when a teacher is gone, who replaces them? A substitute. So if you know that AXD equals angle 1 plus angle 2, and you replace that, this is called substitution. Because you are replacing it with something it's equal to, we substitute it. Now our last step, we wanted to show that angle 1 equals angle 4. Right now, we have angle 1 on the left side, and we have angle 4 on the right side. So we're really close. What do we have to do to show angle 1 equals angle 4? We have to get rid of angle 2 and angle 3. How can you get rid of a plus angle 2? We subtract it. How do you get rid of a positive angle 3? You would subtract it. And if you look at step 1, we said that those two things are equal. So if you subtract these two things, we are subtracting things that are equal to each other. So we can go down here and say measure of angle 1 is equal to the measure of angle 4. And how did we get rid of angle 2 and angle 3? we used subtraction property of equality. I know that looks like a lot. Again, we're going to rep this again tomorrow on Friday. We're going to come back to it next week. We're going to spend time on just how we can make these logical arguments. So we started with the given. We did angle addition postulate. We substituted equal things in, and then we subtracted to get what we want at the end. Okay, if anyone's still writing, you can pause the video, but I'm going to move on to checkpoint 1. All right, checkpoint 1, you do have to add in a letter B. I don't know why, but it didn't show up on the paper. And if you remember, what is the one thing we always start with? The given. So we know that BC equals AB, and that is given. So every single person should always get 1 point, because you should always get the first step right. Okay. If you're ever not sure what to write down on the next step, because like right now you might be kind of confused, like, what do I say next? Look at what you're trying to prove. We are trying to prove something about AC. So we have to write down AC in our statements on the left. So I'm going to start by just saying AC equals. If you look at that picture, what two parts make up segment AC? Because there's two smaller segments in there. You should be thinking, all right, the left part is AB. I take AB, and I add in the right side, which is BC. So AB plus BC, I'm going to get AC. Okay? And what did we add up there? We added up two segments. So this would be segment addition postulate. We'll put segment add postulate. So segment addition postulate means when you add two smaller segments, you get a bigger segment. Now, step 1, we said BC equals AB. What are we trying to prove at the end? We're trying to show that AC equals AB plus AB. If you look at your second statement, this is pretty close. This is the only part that we got to change. So can we somehow change that BC into an AB? And can you think of a reason why? If BC equals AB, we can just use substitution. So we're just replacing the squiggly part with AB because BC is equal to AB. So this is substitution. All right, so moving on to I'm going to head out in a little bit. I'm just finishing up a recording. Okay, thanks. All right, so if you flip over to the back side, we're going to quickly talk about these theorems or these properties because we talked about them on Tuesday. So reflexive property of congruence. All that means is something is congruent to itself. So like segment AB is congruent to segment AB. Or angle C is congruent to angle C. So remember, like look in the mirror, you see yourself in the mirror, the same thing. So reflexive property is like a reflection in the mirror. It's the same thing. Symmetric property. If we talked about segments, we could say something like if segment CD is congruent to segment AB, then segment AB is congruent to segment CD. We just flip the order and it's still going to be equal. Like if x equals 4, 4 equals x. We can say the same thing about angles. If angle x is congruent to angle y, then angle y is congruent to angle x. So it's just saying when you flip around the congruence statement, it's still going to be equal. And the last thing is transitive property. So transitive property is like comparing three things. We talked on Tuesday, it's like saying if Noah is the same height as Hugo and Hugo is the same height as Josh, then Noah is the same height as Josh. Same thing with segments. We can also make a statement about angles. If angle A is congruent to angle W and angle W is congruent to angle Z, then angle A is congruent to angle Z. So these are all the same properties as Tuesday. We're just using congruent statements instead. Okay, and if you need more time, feel free to hit pause. I'm going to continue on just because I don't want to make you wait if you're waiting for me. So moving on to naming a property. Number one, if angle 5 is congruent to angle 3, then angle 3 is congruent to angle 5. Take a few seconds, think about what this might be. Which one of the three properties from above is this illustrating? Right. And if I were in class, I would probably pick on someone like Will or Noah Geschwind, and you guys probably have the right answer. If you do, just feel free to blurt it out. This is symmetric property of congruence. I'm not even there, and I'm willing to bet that those two had the right answer. I'll find out tomorrow when I'm back. Number two, name the property illustrated by the statement. If angle H is congruent to angle T, and angle T is congruent to angle B, then angle H is congruent to angle B. So think about that one. Is it symmetric, reflexive, or transitive? All right. And if you are someone who is blurting out transitive or wrote down transitive, you are correct. This is transitive property of congruence. Okay. And the last thing we have is there's just one more proof that talks about bisecting an angle. All right, so if we're given that BD bisects angle ABC, that's what they're telling us. Always start with your given. Ray BD bisects angle ABC. And that is given. And I know it's a lot of writing. We do have to be detailed, so please write all this down. So if all you know is that ray BD bisects the angle, think about something you can say about that. Like we talked on Tuesday, what does it mean if it bisects an angle? What does it do to that angle, and what happens to the two parts? So if you're thinking that ray BD bisects an angle means it cuts it into two parts and two equal parts, that is correct. It cuts into two congruent equal angles. So we would say the measure of angle 1 is congruent to or equal to the measure of angle 2. And how do we know that angle 1 is equal to angle 2? You would say, well, we were told that it bisects the angle. So our reason will be BD bisects it, or you could say definition of bisects. So definition of bisect. Bisect means cut into two equal parts, so angle 1 is equal to angle 2. Okay, step 3. We're trying to prove something about angle ABC. So let's try to write down a statement about ABC. Because we used step 1, which talked about bisects. We said step 2. Bisects means angle 1 is equal to angle 2. Now, we're trying to prove measure of angle ABC equals something. So let's start by saying something about measure of angle ABC. What two parts make up angle ABC? The two smaller angles are angle 1 and angle 2. So to get ABC, we would add up angle 1 plus angle 2. Okay. Now for your reasoning, what two things did you add up? We added up two different angles. So the reasoning would be angle addition postulate, or angle add postulate. Okay, we actually have two more steps. So looking at step 2, we said that angle 1 is equal to angle 2. And then down here, we have angle 1 and angle 2. We're going to try to replace one of them to say what we want to say. I went a little too far. We want to have two angle 1s on the right side. So what we're going to do is replace this angle 2. Measure of angle ABC is equal to the measure of angle 1 plus, instead of saying angle 2, we're going to say measure of angle 1 because those two things are equal to each other. So we replaced angle 2 with angle 1 because right here we said that they're equal. So this would be substitution because we replaced it. Now our last step, instead of saying angle 1 plus angle 1, we write down angle 1 twice. So we can really say measure of angle ABC is equal to 2 times the measure of angle 1 because there are two angle 1s over there. And all we have to say for this part is simplify. Okay, all that is simplifying or replacing. So this is about the longest proof we're going to do together. You'll never be asked to do something longer than like 5 steps. Right. Okay. Once you have this finished up, you guys can work on the 2.6 homework worksheet. That mainly is properties. There's really like 1 or 2 proofs on there where you have to fill in the blanks. It's not like this where you do the whole thing by yourself. We'll review this stuff again on Friday, and then We'll come back to it on Tuesday because we have no school Monday. All right, I will see you all tomorrow. Take advantage of work time. Try to get that worksheet done. It is definitely doable in class. You can work with partners. Miss Walker will gladly help you out. So take advantage of her if you have questions.